Hey guys, today we're going to talk about GCF factoring. We are starting a brand new unit on factoring. You actually have learned GCF factoring, so today should be a review, but the other forms of factoring are going to be brand new. Okay, so we're going to factor some polynomials today. So first let's talk about what it means to factor. I think the best way to do this is to use an example to kind of show us. So let's say we have something like the following: 12x minus 16. So I think we'd all agree that if we were naming this as a polynomial, we would say it is a binomial. And if the question says to factor using the GCF, because right now that's the only method we're talking about today, then what they mean is they want us to write the expression as a product. Okay? And there's a question about this on the check-in. We're writing it as a product. So here we go. I'm going to work you through all these steps here. The first step is you want to take the terms that are in the binomial, or whatever the expression is, and you want to find the GCF. So if you look at 12x and 16, we're looking for the largest number that goes into both. So the largest number here is going to be 4. Okay? You might be asking, why isn't it 4x? Well, because they don't both have an x, so they don't share it. They don't have it in common. But that is not the only way, or the only factor in this particular binomial. Remember, we're trying to write an equivalent expression. So what we have to now do is we have to take that GCF and we have to find the quotient, meaning we have to take the 4 and we're going to take both terms and divide by 4. And we're going to get 12x divided by 4 is 3x. Negative 16 divided by 4 is negative 4. To get a final answer of 4 parentheses 3x minus 4. The answer is not 4. The answer is not 3x minus 4. The answer is 4 parentheses 3x minus 4. I remember telling my classes when we learned this earlier in the year, it is as if we are undistributing the expression. Now there's a couple of ways to check. One way to check is you could distribute back. So 4 times 3x is 12x. 4 times negative 4 is negative 16, so we know we're good. But the other way we know we're good is you want to make sure that the terms that are in the parentheses, they should no longer share any letters in common or any factors. And you can't put any number into 3 or 4 except for 1, meaning they're relatively prime, if you remember our vocabulary word, which means we're finished. So let's take a look at the second question on the check-in, which is going to ask you to factor a trinomial like this. So I'm going to make a similar question just like that. Why don't we take something like 5x squared minus 25x plus 5. Step 1, find the GCF. If you notice, the GCF of every single one of these terms is 5. They do not all share a letter, even though that middle one and that first one have an x attached to it. The last one doesn't. And now we're going to divide each of these terms by 5. So 5x squared divided by 5 is 1x squared. So you can write x squared. Negative 25x divided by 5 is negative 5x. And positive 5 divided by 5 is positive 1. Double check it distributes back. 5x squared minus 25x plus 5. Double check that there are no letters in common in the parentheses. It's okay for these two to have the x because the third one doesn't. And double check that you can't put any numbers, that there are no common factors in the parentheses. So this is a completely factored form. Okay, next one, same idea. They're giving you a trinomial. They want us to factor out the GCF. I'm going to give you a little hint to this one. Okay, I know right away, just by looking at this bubble, when you do the check-in later, this can't be fully factored because they all have a 2 in common. So I'm just saying that's one little trick that you can kind of do when you do these. All right, so let's make a similar question. 18x squared plus, let's do 12x minus 16. Okay, so the first step is we want to make sure that we are finding the GCF, which in this case is actually going to be 2. and they don't all share a letter in common. And now we're going to divide. 18x squared divided by 2 is 9x squared. 12x divided by 2 is 6x. Negative 16 divided by 2 is negative 8. They don't all share an x, so we know we're good with there. Even though the 9 and 6 can still be divided by 3, the 8 can't be. So we know that it's all relatively prime. And if you distribute back, it will distribute back to this polynomial. Okay. 2 more. What is the complete factored form of 30x minus 45? The reason they say complete is maybe some of these multiply back to 30x minus 45, but it's not fully factored, meaning using the GCF. So an example, 18x minus 12, if we wanted it completely factored, we would choose the GCF of both numbers, which would be 6, and we'd end up getting 3x minus 2. So this would be a completely factored form. If you wanted something that was not completely factored, just to give you an example, what if a student thought that 2 was the GCF? Then you might have something like 9x minus 6. But this is no good. Why is it no good? Because look, 9 and 6, they both share a 3 still, which means you didn't take the largest number out. And finally, it says factor the 4 expressions. Which 2 expressions share a common factor? So I'm going to give you a very similar question. Let's do 5x plus 25. Let's do 7x plus 21. 3x plus 15, and we'll do, how about 2x plus 4. Okay, so if we put these all in factored form, GCF here is 5, which means you get x plus 5 in parentheses. GCF of the second one is 7, which means you get x plus 3 in parentheses. GCF of the third one is 3, which means you get x plus 5 in parentheses. GCF of the last one is 2, which means you get x plus 2 in parentheses. And the question is, which 2 share a common factor? So you want to look at all the factored forms, and if you notice, in the first one and the third one, they share a common factor, x plus 5. Okay, so that's what they want you to do here. Factor, 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 and then look at all of the factored forms, and 2 of them are going to have a factor in common. Okay? All right, guys, so you're going to try the check-in. Make sure if you need any help, you come back to the video, you pause it, you rewind. We're also going to have a Zoom lesson today, so come to the Zoom if you have any questions. We will also obviously be available via email or on Google Classroom, and you can send us a question at any time. Okay, and the check-in's due by 5 p.m. All right, guys, see you later.